Hello, this is the homework for day 4 of the distributions unit. We're going to be talking about z-scores and inverse probability questions for Ms. Sorrentino and Mr. Kenzie's classes. To start off, z-score is the distance of standard deviations above or below the mean. If it's negative, it's below the mean, and if it's positive, it's above the mean. Z-scores can then determine the probability that a subject picked from a normally distributed population would have characteristics in a various range. We know that we are going to use inverse of probability. If we're given the mean standard deviation and asked to find a value that corresponds to a certain percentage or percentile. The inverse of probability problems, we use the INV norm function, which is option 3 from second VARS. So getting to our questions. Number 1, the population has a mean of 24.8, a standard deviation of 4.2. For each of the following data values, calculate the z value to the nearest hundredth. You do need to read the normal table. Do not need to. So what we're going to do is we take, so for example, data point 30, we subtract the mean from that, and then we divide by the standard deviation to get approximates. And I rounded to so this would be 1.24 standard deviations above the mean. A question like this, where we took 15.4, subtracted the mean, and divided by the standard deviation, this would be negative 2.24 below the mean. Standard deviation is below the mean. So those are our solutions. Looking at question 2, a population has a mean of 102.8 and a standard deviation of 15.4. If a data point has a z-score of 1.87, then which of the following is the value of the data point? So what I did, we know the z-score is 1.87, so I just plugged it into the same thing we did before. All right, but in this case, we're looking for the actual value. So subtracting the mean and then dividing by the standard deviation. So all I did, I put this over 1, and cross multiplied, then added 102.8 to get a value of 131.6. So we just solved it algebraically. Number 3, 4, and 5, I used normal CDF once again. And this is because they gave us a mean, a standard deviation, and then kind of gave us an in-between, or how many people or percent of people fit in a certain area. So in question 3, a recent study found that the mean amount spent by individuals on a music service website was normally distributed. So that tells us we're going to use normal CDF with the mean of 384, the standard deviation of 48. Which of the following gives the proportion of the individuals that spend more than $400? So more than $400. So I did 400 as my low end, 10,000 as my high end. I then also have my mean and my standard deviation to get an answer of choice 4. For number 4, this one said less than 5 minutes. So I have 0. You could have put negative 10, negative 20, negative 100. You still should get a close approximation. So I have 0, 5 for my higher number, the mean, and then the standard deviation. For number 5, now this one says you want to lie in between 2 and 3. And we're talking about gasoline, so that's why my lowest was 2, largest was 3, mean, standard deviation. To get 90%. You would get a decimal and you would multiply that times 100. If it asks for the proportion, you're going to leave it as a decimal. If it asks for the percent, that's when you're going to multiply by 100. Just make sure you read the directions carefully. All right, taking a look at the next example. For here, all right, we are looking at, so for number 6, if the average teacher's salary in the United States is $45,753, and the salaries are normally distributed with a standard deviation of $7,890 and a salary of $40,000 per year, being the lowest quintile of teacher's salary. So you got to look up what quintile was. That's basically just dividing into 5 parts. So I have that here. All right, I also did a kind of a bell chart. to kind of show what that meant and where they were getting. So I took what we normally were used to with our bell chart, normally distributed, and I kind of did in 5 equal parts. So no within the third quintile. So we're talking about that salary of $40,000. $40,000 would be somewhere in this area, all right, which would be in the 1, 2, 3rd quintile. Number 7, the average rent for a 1-bedroom apartment in the winter of 2015 in New York City is a whopping $2,801 per month with a standard deviation of $920. So for this one, for A, I used normal distribution because it was less than 2,500. I put 0 because you can't have less than that, but you could put negative 100, negative 1,000, and you still should get about the same answer. Here, this was my mean. Once again, my standard deviation. I got about 37%. Rounding to the nearest tenth, you would get about 37.2%. B, this one says if rents are normally distributed, how realistic is it to believe you will be able to rent a 1-bedroom in New York City for less than $1,500? So less than this, so that was my maximum. My lowest, once again, was 0. You could have put negative 200, negative 1,000, about 7.7%. So is this realistic? No, it's not very realistic. It's only 7.7%. It'll be less than that. C, another normal CDF, we're talking so 5,000 a month or less. So how rare is this? So I have 5,000. I put it 0. Mean, standard deviation. 99% of the apartments are $5,000 or less per month. So above that, this is the 99th percentile. All right, so $5,000 or more is very rare. D, skewed right just because it's more expensive. Wondering if it would be symmetric, and I don't think it would be in New York City. You have a lot of various prices, but it's usually very costly. Now for these, once again, we are going to be using the inverse, all right, of the, so our inverse of our normal probabilities. For this one, we would take, all right, once again, and use our calculator. We're using choice 3 once again. So the inverse norm, choice 3 on the calculator, pushing second in vars like we had been using. And then we just type in those values. So like, for example, if I did choice 3, we're going to type in our area. So our area for this, all right, is 0.95. We have our mean, which is 76.2, and our standard deviation, which is 17.1. Make sure you plugged in everything correctly. And so 104.32, so using the z-score, all right, so it'd be 104 or 105. The next one, and last problem, this says, Andrew scored 500 on a standardized test, which has a mean of 600 and a standard deviation of 75. Jill scored 150 on a different standardized test, which has a mean score of 190 and a standard deviation of 40. Assuming both tests have results that are normally distributed, compare their peers. All right, which person did it better on their respective tests? Explain. So I took Andrew, and we took his score, subtracted from the mean, all right, to find what the actual z-score was, and then divided by the standard deviation. Did the same thing with Jill. Now Andrew's was negative 1.3 repeating below. Standard deviation is below. Jill was negative 1 below, so hers was closer to the mean. So Jill did better because she had a higher z-score. Thank you.